So whatever we have done in the previous class, we will continue from there. In the previous class, I gave you some properties. I will continue with those properties which I gave at the end. Like the first property I will discuss over here is A minus B set is same as A intersection B complement set. Again, I repeat, if you want to understand these properties, you have to take some examples of set A, set B, and show that the left side set will be same as right side set. Okay, the second property is the set B minus A is same as the set B intersection A complement. The third property is A minus B set is same as set A implies A intersection B is empty set. You can say in the reverse way also. If A intersection B is empty set, that implies A minus B will be equal to A. The fourth property is the set A minus B union B is same as A union B. The fifth property is the set A minus B intersection B you will get is empty set. And the sixth property is A minus B union B minus A is same as A union B minus A intersection B. So after these properties, we will go to the definition of Cartesian product of sets. For this, we need two sets, A and B. A and B are two sets. Then I can find the Cartesian product A cross B by making ordered pairs x comma y. But remember, x I have to take from the set A and y I have to take from the set B. Make all possible combinations. Similarly, if you want to make B cross A, then the ordered pairs must be y comma x, such that y you will take from the set B and x you will take from the set A. All possible combinations. Usually, in general, A cross B will not be equal to B cross A. But sometimes, that is, if the set A is equal to set B, then I can say definitely A cross B will be equal to B cross A. Or I can say in the reverse way, like if A cross B is equal to B cross A, then definitely A will be equal to B. I'll give you one example for this. Then you will understand better. So for this example, I will take A having 1 and 2. I'll take the set B having A and B. So if I want to take A cross B, I have to take all the x's from A, all the y's from B, and make x comma y. I have to make x comma y in all possible ways, like 1 comma A, 1 comma B, 2 comma A, 2 comma B. Similarly, if I want to make B cross A, I have to take all y's from B, all x's from A, and make y comma x. That is, I'll make A comma 1, A comma 2, B comma 1, B comma 2. So clearly you can see A cross B is not same as B cross A. Then, apart from this, I can tell some more things about the Cartesian product. Like if number of elements in the set A is m and number of elements in the set B is n, then the number of elements in the set A cross B will be m into n. And the number of elements in the set B cross A will be n into m. After this, I can tell you some more properties based on cross products. That is, if A cross B, you will get empty set, then either A should be empty set or B should be empty set, or both A and B should be empty set. Then the next property is A cross B union C is same as A cross B union A cross C. Again, to understand more about this property, you have to take examples for the sets A, B, C and show that left side and right side you get the same answer. The next property is A cross B intersection C is same as A cross B intersection A cross C. The fourth property is A cross B intersection C cross D is A intersection C cross B intersection D. The next property I can take on the next page. The fifth property. If A is subset of B, then definitely A cross C will be subset of B cross D. Similarly, if A is subset of B, then definitely A cross A will be the subset of A cross B intersection B cross A. And now the property which I'm telling is very, very important. Suppose if number of elements in the set A is m, number of elements in the set B is n, and number of elements in the set A intersection B you have to take, that is P. That means the common elements in the sets A and B is P. Then if you take A intersection B elements, the number of elements in A intersection B, if you take P, then let us take A cross B intersection B cross A set. In this set, the number of elements will be P square. This is the shortcut method. If you want, you can go for an example over here. Because we don't have space here, we will go to the example in the next page. Remember, if you take examples, you will understand these properties very well. So always we will do that. Sometimes for few things, I will give you examples, but for others, you have to take. Okay, let me take a set A having elements 1, 2, 3. So you can see number of elements in set A is 3. Now I am taking B as 2, 3, 4. Number of elements in the set B is also 3. If I take A intersection B, I will find two elements, that is 2 and 3, common in both the sets. That means number of elements in A intersection B is 2. So if I find A cross B and B cross A, and if I take intersection, the number of elements in this will be this 2 being squared. I will have 4 elements. If you want, you can check it. This I told you using shortcut method. So first, in a long method, I will write what is A cross B. A cross B will be 1, 2, 1, 3, 1, 4, 2, 2, 2, 3, 2, 4, then 3, 2. What else you have? 3, 2, 3, 3, 3, 4. Isn't it? Same way, we will find B cross A. What do you have in B cross A? 2, 1, 2, 2, 2, 3. 3, 1, 3, 2, 3, 4. Then 4, 1, 4, 2, 4, 3. We will take A cross B intersection B cross A. This is the set. What are common in both? You can see 2, 2 is present in both. So I will write here. What else you can see? 3, 3 is present in both. 3, 3 is here. This is 3, 3. So 3, 3 is present in both. What else you have in both? 2, 3. 2, 3 is here. 2, 3 is here. It is present in both. What else you have? 3, 2. 3, 2 is also present in both. So total, how many elements you have? Number of elements in A cross B intersection B cross A is 4. Only these are common. Nothing else common. See, 1, 2 is not common, 1, 3 is not common, 1, 4 is not common, 2, 4 is not common, then 3, 4 is not common. 2, 1 is not common, 3, 1 is not common. Okay, 3, 3 we have taken common. 4, 1 is not common, 4, 2 is not common, 4, 3 is not common. So without doing this, I have used shortcut method and I told you that the answer will be 4 for number of elements in A cross B intersection B cross A. So shortcut formulas will be like this. We will take one more small example. Suppose if I give you A as 1, 2, 3, 4. B I will give you as 2, 3. Then I will ask you what is the number of elements in A cross B intersection B cross A. So how will you find? First of all, I will take A intersection B. What are the common elements? 2, 3. So number of elements common in A and B are just 2. So if I want number of elements in A cross B intersection B cross A, the shortcut method is I will take this 2 and I will square it and I will say total 4 elements you will have in this particular set. That's it. See how easy it is. In 1 second, we can do it. Let us take some more properties with cross product, with unions, intersections, complements, all are included. Let us take in the next page. Number of elements in the set A minus B is number of elements in the set A minus number of elements in the set A intersection B. This is the first one. Second one, number of elements in A symmetric with set B will be number of elements in the set A minus B union B minus A. That is the number of elements in the set A minus B plus number of elements in the set B minus A. Or you can even say it will be number of elements in the set B plus number of elements in the set A minus 2 times number of elements in the set A intersection B. So here I'm telling about symmetric difference of A and B. Take the symmetric difference of A and B. How can you find the number of elements? You can find using these three formulas. Any one you can use. The third property is number of elements in the set A complement intersection B complement will be number of elements in the set A union B complement. Or you can even say number of elements in the universal set minus number of elements in A union B. Similarly, number of elements in A complement union B complement is number of elements in A intersection B complement. Or you can even say number of elements in U minus number of elements in A intersection B. The fourth property is if you want to find number of elements in A union B union C, 3 sets, you have to take number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in C intersection A plus number of elements in A intersection B intersection C. Coming to the fifth property, the number of elements in exactly 2 sets of A, B, C. For example, I will give you 3 sets A, B, C. Any 3 sets. Make any 3 sets. Now, I want to find number of elements in exactly 2 of the sets. Exactly 2 of the sets. So, I will write like this in sentence. Number of elements in exactly 2 of the sets A, B, C. Out of A, B, C, any 2 sets we take. So that you can write it as a formula. Number of elements in A intersection B plus number of elements in B intersection C plus number of elements in C intersection A minus 3 times number of elements in A intersection B intersection C. This is one formula. But if you want to find number of elements in exactly one of the sets A, B, C. For that, there is a different formula. Number of elements in A plus number of elements in B plus number of elements in C minus 2 times number of elements in A intersection B minus 2 times number of elements in B intersection C minus 2 times number of elements in A intersection C plus 3 times number of elements in A intersection B intersection C. So with these, we have completed a few properties. The next few properties we are going to learn in the next class. I'm going to end this session.